Hello everyone, I am Abhishek. This video is for assignment 5 given in the subject of mechanism sessional. Me and my group members Abhishek and Deepan have solved question number 4, which is the synthesis and simulation of a flip-up garage door mechanism without using any prismatic or higher pair joints. This is the side view of the mechanism given in the YouTube video for our reference. It may be a little different from our final synthesis. And it's the kinematic diagram of mechanism, which is a 4R mechanism. The door frame acts as the fixed link, whereas the door is lifted up with the help of two links. Calculating degree of freedom, we have number of links equal to 4, that is ground and the links, and number of joints equal to also 4. So sigma fi equal to 1 for each revolute joint. So using the number of links, number of joints and sigma fi, we will get degree of freedom equal to 1.
Myself Abhishek proceeding to show the synthesis of our mechanism, and here is a reference diagram of our mechanism. Figures show the initial position of flip-up garage door mechanism, and from this initial position we get a relation L1 plus L2 minus L4 is equals to L3, and L1, L2, L3 and L4 is labeled in previous diagram. And for the smooth entry of the car, the door should reach as high as possible. So possible final position is door is perpendicular to the garage frame, that is L3 is perpendicular to L1. From the final position we get the equation, that is L4 cos phi is equals to L1 plus L2 cos theta, and L4 sin phi is equals to L3 minus L2 sin theta, where theta and phi are shown in the figure. Now we have three equations, one from initial position and two from final position. We have named that as 1, 2 and 3. We have total 6 variables, so we need to assume at least 3 variables so that we can define the whole mechanism. Assume that L1 is 6 unit, L2 is 14 unit, and after several trial we get a decent assumption that theta is 109 degree, for which the area occupied by the lifted door is quite small. We will eliminate phi by using equation 2 and 3. We will square, and adding both the equation we get L4 square is equals to L1 plus L2 cos theta whole square plus L3 minus L2 sin theta whole square, and we name that as equation number 4. Now we eliminate L3 using equation 1 and 4. We get L4 whole square is equals to L1 plus L2 cos theta whole square plus L1 plus L2 minus L4 minus L2 sin theta whole square. We name it as equation number 5. Solving the equation 5 by substituting L1 is equals to 6 unit, L2 is equals to 14 unit and theta is equals to 109 degree, we get L4 is 3.6 unit and L3 as 16.4 units. Thus, it completes the synthesis of our 4R mechanism.
I am Deepan Laha and I will explain the simulation of the model. Now here I have used Python to make simulation. As found while synthesizing, I have used the total garage frame length to be 20 units and the total door length is taken as 16.4 units. The two supporting link lengths have length 14 and 3.6 units each. I have approached the simulation in a simple way. In the figure, we can see that the locus of A is that of a circle with O1 as its center. At any time, let the position of A be as shown in the figure. Now we know the lengths of AB and BO2 as the link lengths that we have synthesized. So, taking A as the center, a arc of radius AB is drawn, and taking O2 as center, a arc of radius O2b is drawn, and the intersection point of these two arcs will give B. thus completing the 4R mechanism at any time of the motion, and it is the completion of the simulation. Here's a screenshot from the simulation. The yellow part represents the door frame, the red part is the door, and the green ones are the supporting links. Here's the simulation formed using the Python code.
Lifting of the garage door. In the reference video, it is shown that for opening the garage, weights are hung on the links on each side. But it can be quite troublesome. So we can use a torsion spring at the top of the door as shown, which will make it easier for us. A lock should be built at the bottom of the garage door, which should be locked after closing the door to prevent sudden opening of the door. Also, the reference link is given. Another possibility is to add two normal springs at the extended end, the end which is attached to the frame of the link L2 and connecting it to the bottom of the frame. Electric garage door operators bring both safety and convenience. An electric garage door operator should incorporate safety features, which ensure the garage door will stop if an obstruction is made during its operation and reverse to prevent damage. This safety feature is built into all proper CE compliant modern electric operators and relies upon the garage door being properly balanced as a manual door. So the safety reverse feature does not receive false readings due to heavy or sticky spots in the door operation. This will give us a remote control door that keeps stopping for no apparent reason and defeat the object of door automation, convenience.